started. All right. Any specific one you'd like, or just the whole thing? Oh, okay. Oh, yeah, it is. Okay. So let's predict the product and propose a mechanism for the elimination reaction that results when we have the S1 chloropropyl benzene, which is right down there. Okay, so it is heated in the presence of this right here. So what we're looking for is some sort of elimination reaction, right? And what is an elimination reaction again? Well, the most likely elimination mechanism for this is going to be, well, you have E1 and E2, right? How do you choose between E1 and E2? Do you have a good leaving group versus do you have a good base? Okay? That's not really a great base, is it? That's just ethanol. Yeah, it's alcohol like you drink, right? Not super reactive, is it? No. So you're probably not going to have an E2, right? Which would require something strong attacking. You're probably going to have a self-elimination, right? Something that starts off by itself, because that's a pretty decent leaving group. Chlorides come off as chlorides pretty easy, don't they?
Is it all the halogens?
Almost all the halogens come off easily. The only one that's not stable by itself is fluoride. And that's because it's so small. It's just so small that its charge is very centered. It's like this little ball of negativity. It's unpleasant. It's a big bully, and it's a little ball of negativity, isn't it? All right. So the first step of this mechanism is likely, well, the chloride comes off, right? And it takes its electrons with it. That would give us a carbocation. And so now we have over here your carbocation, right? Okay. We were told to do the elimination reaction, right? So we're going to do the elimination reaction. One of the questions that people that have a pretty good grasp of this material might come up with is, Dr. Clausen, why aren't we doing like an SN1 here? I mean, you could get ethanol reacting with a carbocation, right? And yeah, you're right. Yeah, you could have like an SN1 reaction. That's a doable thing. So this one, though, is an elimination, right? And so now we have a positively charged hydrogens over here. They will be more acidic than they would normally be because we have a positive charge draining them of electron density, right? Okay. Or other ways, we have another place that's going to take their electrons. Does that make sense? Fantastic. So one of these hydrogens is going to come off. Why is it not a hydrogen over there? A hydrogen over here on the other side? There's no hydrogen. 1, 2, 3, 4 bonds, right? It's a trick question. It was a trap. Okay. Yeah, so these are the most likely, right? Could you get rearrangements? Yes, you could actually get rearrangements, but they're not super likely in this case. Okay? Anyways, it just sort of wanted a direct E2 or E1 mechanism is what really was looking for. So we're going to have the oxygen here. It's going to take that acidic proton. That will leave you with an H2O plus off of this ethanol, right? Okay. That will also leave you with a negative charge that's going to go into this bond so that you have a double bond, which is what you always get when you do eliminations, right? That's how you can eliminate something from there, is you always put those electrons into a double bond.
So you're saying for elimination reaction, you're always going to have this bond somewhere to create.
Yeah. Yeah, you gotta make a double bond because you just eliminated something off of it, right? Typically, you've eliminated like HCl, HBr, something like that, right? Okay. And so we then have our H2O plus right down here on that ethanol. We still have our chloride, don't forget, it doesn't go anywhere. It's just floating around. And then we have a double bond between these two carbons. And again, we couldn't have done it the other way because it already had its 4 bonds, right? It didn't have a hydrogen to eliminate. Okay. Does anybody have any questions? Yeah, I mean, all of these things are really just inevitable conclusions to rolling down a hill, right? You just got to be able to see the hill. You got to see the causes, and then everything that happens in organic chemistry is just the inevitable conclusions to them, right?
So when the hydrogen gets pulled off and goes to oxygen, the leftover electrons will then form a bond with
The carbocation, right? Because otherwise you'd have a negative charge here and a positive charge right next to it. So it has to go into a bond, double bond, right? Yeah. Does that kind of help people? Okay. Does that make sense? Nobody got lost or anything? Huh? Okay. Yeah, honestly, organic chemistry is one of those things that you could spend 10 hours, you could spend 1 hour. It's going to come when it comes. And all you can really do is just build up your base, build up your terminology, build up your memorization, and work problems until it does. It's an understanding, and you have to click first, right? And until you click, I mean, you could spend, some people spend an hour or 30 minutes even, and it clicks. Some people spend 20 hours on something, and it finally clicks, right? Eventually it will, but until you do, just work problems. It's the best thing you can do. Okay, I'm going to stop there.